Okay, so let's finish this one. We're going to add them in fractions. Okay, so the first one, show how to write the answer as a fraction and as a decimal. So I could do this by converting this into a fraction, which I know a quarter is 1/4 of a dollar. And I could scale this by 4 to get, what, 8/20ths. And I could multiply both of these by 5 to get 5/20ths. Because remember, your goal is to get the same unit. So and then I could add those and combine those. So what is that? 13/20ths. And that's one way of doing that. The other thing is I could convert this to a decimal. And so again, 2/5, decimals are base 10. Oopsie. So if you can get it into a 10, that's a great idea. So times 2 is 4/10, which would be a 4 in the tenths position. All right. And so I could add, again, 0.4 plus 0.25. If you don't know how to get that in a 10, then you have to put the 2 in the little house thing and the 5 on the outside and then put a decimal and do division. Like 5 doesn't go into 2, 5 goes into 24 times, and then you get 0. And remember, the decimal comes straight up. So you have to be able to do that without a calculator. Again, units that are like, you don't really line up the decimal. That kind of happens by accident. You line up the place values. So hundredths with hundredths, tenths with tenths, and when you do that, the decimal automatically lines up. All right, so 0.65. So I can do decimal work to do decimals. I can do fractions. And if I want to really make sure those are equivalent, 0.65, I could scale this one up by 5 and 5 and get 65 out of 100, which is 65 hundredths. So I know I'm right. All right, let's look at the next one. Part B, you have 3.8 and let's see, 3/8. All right, so make sure I got that right. So if I want to do decimals or fractions, if I want to do fractions, this would be 3 and 8 in the tenths position. So 3 and 8/10, and then I have 3/8. Common denominator, I could use 80, but do you guys see that 40 is actually smaller, so more precise. So times 4 times 4, 32 times 5 times 5 is 15. Again, I can combine my units because they're the same now. So that is 3, and what do I have there? Is that 47/40ths? And again, this is top heavy here, that means I could put like 40 of them in a box, right, and make a unit out of it. So I'm going to make 4, and then there'd be 7 left over, okay? Because if I take 40 and put them in a box, I get another whole, but then I'd have 7 left. So it looks like I get that. If I want to do decimals on that one, all right, you might not think it's as nice because you're like, but 3/8 isn't pretty. But remember, that's one that you should know how to do because you should know that a 1/4, which is the same as 2/8, right? If I scale times 2 times 2, and you should know a 1/4 is a quarter, okay, or 25%. So an 1/8 is half of that. So if you know a 1/4 is 0.25, you should know that half of that would be 0.125 because half of $25 is $12.50. Half of 0.25 is, 0.125. So you should be able to calculate that. So 3/8, if I combine those, would be 0.3 if I line up my decimals, 7, and then line that up. So 375. And again, a lot of people have that memorized. Okay, that's not that uncommon to have it memorized. So again, you want to line up your place value, which means your decimals will line up, because if your thousandths line up and your hundredths line up and your tenths line up and your ones line up, your decimals have to line up. All right, so then I'm going to add those together. So 5, that's a 0. So 7, I get 11. And again, we need to regroup. So 4.175 or 4 and 175 thousandths is the official way. Now, what about if I want to do fractions? That might actually be easier in this one. This is 3, this is 8 in the tenths position. Okay, gonna get a common denominator of 40 again. That seemed to work the other time. So times 4 times 4. Oh, do I want fractions on this one, or did I do fractions already? Oh, I guess I did them both. Oh my gosh, I am so sorry. Oh well. I'm like, I already did this. This looks familiar. All right, so then we get the same answer. So we had what we have before, 4 and 7. 4, well, I lost my pen. Okay, everything's going downhill now. So I have 4 and what did we get before? Sorry, 4 and 7/40ths. right? And that is equal to, what do we get up here, 4.175. Okay, and if you're not believing, right, you could take 7 divided by 40, and you could clarify that. Oopsie, sorry, there we go. Or you could do division on that one. All right, so the question is, what errors might kids make? All right, so, I mean, on this one we just did, it's possible that a kid might, if they're converting this to a decimal, they might just call it 0.3, you know, not paying attention that's not in base 10. The other thing here is they might call that 3 1/8, so they might view that as like a denominator and not the numerator. That's a possibility. Trying to think, on the first one, what we have there, 2/5 and 0.25. Again, this one, they might just put like, who knows, 25/10, right? They might not know that it's a fourth. They might not know that if you're going to do that, it'd have to be over hundredths because the last digit's in the hundredths position. They might just look at the 2. The other thing is they might just go 2/5, like shove the first number in the numerator, the second number in the denominator. To convert this to a decimal, they might just go 0.2, you know, so they just, again, put that in that position. So there's lots of errors that kiddos can make when doing this kind of math. All right, let's look at, let's see, do we have 2 more here? Yeah, let's look at 13 and 14. All right, so 13. So if it's an adding story problem, remember it has to be a join or put together, like I have 3 apples, you have 4 apples, we have this many together. So it'd have to be I have 3/4 of a cup of flour, you have 2/3 cup of flour, we dump them together in the bowl. How many cups of flours do we have? So it has to, the units, I mean, even what I'm dumping together, right, has to kind of match here. So I have 3/4 cup of flour dumped in with 2/3 cup of flour. How many cups of flour do I have? Or it could be, you know, part whole where they're different things. But again, usually it's an add or put together. All right, so let's look at the first one. It says, this is number 13. It says, in Neben County, half of the female voters and 1/3 of the male voters are in for this certain referendum. All right, so again, think of your wholes. They're not necessarily the same. So like maybe there's tons of females and maybe the male population is lower, right? And so what does it say? Half of these guys are for it, and then what? 1/3 of these guys are for it. If I can cut in thirds. So the problem is, I mean, you don't know that you have the same number of people or males or females. So, you know, they're most likely different numbers. So you need to figure that out. I mean, you can't do that. So you can't add these because you're taking half of a quantity, right? It's not just a half quantity. It's not just a half a cup of flour. It's a half of some value. It's like a half of some number plus, you know, whatever, 1/3 of some number. You need to know what that number is. It's just not, you're not adding a half a cup with 1/3 of a cup where they're the same unit. So you can't do that. The second one says about voters, half of the female voters and 1/3 are male voters would vote for a certain referendum. There are the same number of women and men now. You know, altogether, what fraction of the voters? Okay, so now you're like, ooh, this must be right now because, right, our wholes are the same, all right? Okay, but let's think about it. There's still a value associated with it. So here, say X is the number of females, and again, men is the same, so the circle should be the same size. So the number of voters we have here is half X. The number of voters I have over here are the men, and I have 1/3 of X. But let's read the question. It says, altogether, what fraction of the voters? So it's saying what fraction of the voters. So if I want to know what fraction of the voters, I do have to add these up. But do you get that I have to divide by the total number of voters? So I have half these voters, 1/3 of these voters, but what's my total here? Well, my total number of voters is 2X. So so after I get a common denominator here, so times 3 and times 3 times 2 and 2. So what is that? 3, 6 and 2, 6. So I have 5, 6X. I'm going to have to divide that by 2X. So it's actually going to end up, the X's will cancel, but it's going to end up being half of 5, 6. It's not going to be just the 5, 6. And if you need to put a number on that, that might help. So say, I'm going to pick a nice number that works with that. So say there's 6,000 women and 6,000 men. Then you can put a number on it. Half of 6,000 would be 300 or 3,000 people, 3,000 women. a third of this divided by 3 would be what? 2,000 men. So, but again, my total population, they want to know what fraction of the total population are going to vote for this. So my 3,000 women and my 2,000 men are 5,000 people. But out of what total? Well, my total is both circles together. So my total is what? 12,000? Is that, oh, is that right? Yeah, 12,000. Okay, because 6,000, 6,000. All right. So my zeros cancel and I get what? 5/12 of the population vote. Now notice 5, 6 divided by 2. If you multiply by the reciprocal, you take half of it. Do you see how I get that 5/12? So sometimes you have to put numbers to it, but again, you're taking half of something, a third of something, and then you're comparing it to the whole. So that makes a difference. All right, let's look about the subtraction one. We'll end on this one. All right, so number 14, it says, so subtraction, remember, is like take away, right? So I have 1 3/4 cups of flour. My friend borrows 7/8 of a cup of flour. How much flour do I have left? Okay, so it's kind of, you're taking away or you're separating. Remember the word separate when we did CGI. So those are the problems that lead you to subtract. All right, so this one, can the following problem? You have, let's see, how does it say? All right, a bird feeder was filled with 3/4 of a full bag of birdseed. The birdseed ate half of what was in the bird feeder. What fraction of the full bag of birdseed did they eat? Okay, so here we have this, full bag, 3/4, which is great, right? So it's 3/4. But it says that a bird ate half of that 3/4, okay? It didn't say that you had 3/4 of a cup of birdseed and the bird ate half a cup of birdseed. How much birdseed is left? It says that the bird ate half of what you have. All right, that's multiplying of fractions because you're taking half of the 3/4. So I'm going to need to find another one. So you're taking half of the 3/4, which that is not subtraction. When you're taking part of something, that is definitely multiplication. So 3/8 of a bag. All right, so then the second part says, okay, let's fix it. Bird feeders filled with 3/4 of a bag of bird seed. All right, the bird ate half of what was in the bird feeder. What fraction of the full bag is left? Okay, so again, we have that 3/4. All right, so we have 3/4 of the, and then it says, okay, so the bird ate half of what was in there. All right, so half. And it wants to know what's left. Okay, now it happens that this is left, but not for the same reason. This would be, let's see, you would have, how much do we have to start out with? We have 3/4 of a bag to start out with. The bird is taking away what? They're taking away half of 3/4, okay? And so they're eating this much, all right? Now the reason that's left is, we'll do the math here. So minus what? 3/8. Get a common denominator. So 6/8 minus 3, oh boy. Minus 3/8 is 3/8 of a bag. So that just kind of, because this was double that amount, that's why that worked. It normally would not work. But again, when you're taking a fraction of something, that's multiplication. And then when you're taking that away, you're just kind of subtracting that part, and then you're focusing on what's left. All right, so again, trying to remember some things from 114, like what is an add problem, what is a story problem that deals with multiplication, what is a story problem that deals with this, that, and the other. So we'll work on that tomorrow or the next day. So anyway, hope that helps. Take care. Bye-bye.